Hi everyone, Miss Phelan here. I hope you're doing well and staying safe and healthy. Today we are going to learn about igneous rocks. Okay, so there are three types of rocks: igneous, sedimentary, and metamorphic. In this video we are focusing only on igneous rocks. Igneous rocks are made when magma or lava solidifies, which means it turns from a liquid into a solid, and it changes from magma or lava into a solid, hard rock. How do they form? Igneous rocks are formed when magma or lava cools to the point where it solidifies into rock. That magma or lava turns from a liquid into a solid and becomes hard rock. Remember from our previous lessons that magma is molten or melted rock beneath Earth's surface. So if you look at this picture here, this magma is underneath the surface of the Earth. It's inside of the Earth, so it's magma. Magma is inside the Earth. That magma will sometimes come out to the Earth's surface through a volcano or maybe through a crack in the Earth's surface at a divergent plate boundary. Once that magma comes up to the Earth's surface, we call it lava. So lava is molten rock above the Earth's surface. If you see in this picture here, we have a volcano, and that magma is erupting out of the volcano. Once it comes out of the volcano and it's on top of the Earth, we consider it to be lava. So how do we classify igneous rocks? Remember, to classify means to sort. How do we sort the different types of igneous rocks? We classify igneous rocks based on their environment of formation, where they form. Okay, the environment of formation is like saying where these rocks formed. So there are two environments that igneous rocks can form in. One is inside of the Earth, and the other is outside of the Earth, on the surface. We'll start with intrusive rocks. Intrusive igneous rocks form when magma solidifies below Earth's surface. Okay, intrusive igneous rocks form when magma solidifies below Earth's surface. Look at this picture. You can see we have a pool of magma inside of the Earth. It's not outside on the Earth's surface, it's inside the Earth. And that magma doesn't always stay magma. Just because it's inside of the Earth, it may not be hot enough to stay liquid. So it might start to cool and form solid, igneous, intrusive rock. You can remember intrusive by thinking that they form in the Earth, right? The word in is in the word intrusive. These igneous rocks form inside the Earth. What do intrusive igneous rocks look like? Because these rocks are cooling inside of the Earth, they cool very, very slowly. And so because they cool very slowly, there is a lot of time for very large crystals to form in the rock. So we know that a rock is an intrusive igneous rock by noticing that it might have very large crystals. And those large crystals form because the rock cools very slowly, allowing enough time for these large crystals to form. We can compare intrusive igneous rocks with the second type of igneous rocks, extrusive igneous rocks. Extrusive igneous rocks. Extrusive igneous rocks form when lava solidifies above or on Earth's surface. Okay, this is when it's lava. The lava has erupted out of a volcano. It has come out of a divergent boundary. The lava is on the surface of the Earth, and that's when it solidifies and forms a new rock. Look in the picture here, we can see we have our lava on the outside of the Earth's surface. Extrusive rocks form outside of the Earth, on Earth's surface. You can remember extrusive by thinking the lava exits the Earth and then cools, right? We have intrusive, the magma is cooling inside of the Earth. Extrusive, the lava exits the Earth and then cools. What do extrusive igneous rocks look like? Because these rocks form when very, very hot lava exits the Earth and is outside on the surface of the Earth, there's a big temperature gap between the very hot molten lava and the Earth's cool air or cool ocean water. And because there's that huge temperature difference, the extrusive igneous rocks cool very quickly because the lava is exposed to the air or ocean and cools very quick. Because these extrusive igneous rocks cool very quickly, there isn't a lot of time for big crystals to form. So in an extrusive igneous rock, the faster the molten rock cools and solidifies, the smaller the mineral crystals will be. Extrusive rocks have very tiny or small crystals. We will often call them fine crystals. Fine is a synonym for small or tiny. We would say they have fine crystals. If you look at this rock in the picture, you can't even really tell that there are crystals in the rock because they are so small. You almost need a microscope to be able to see the tiny crystals that are inside of this rock. Sometimes no crystals form in the rock. Sometimes the igneous rock, the extrusive rock, cools so quickly that crystals aren't able to form. The rock might even cool so quickly that gas in the lava gets trapped in the rock and then ends up creating holes from the gas bubbles that were stuck in the rock. So in this case, we might get a rock that has holes in it. Extrusive rocks can cool so quickly, gas bubbles get stuck. The rock then has holes. Our vocab word for this is vesicular. We call this rock a vesicular rock, which means it has holes in it. It kind of looks like a sponge, except it's really hard. Most commonly, we see this rock in the form of pumice. Okay, you might know pumice if you've ever gone to a spa. We often use pumice on our skin to help exfoliate and take away the dead skin cells. Okay, so you might have seen this rock before. You can sometimes see it in the supermarket or in the pharmacy near the nail polish. Anything that has holes in it, like this rock here, is likely to be pumice. So now we are going to sum up what we just learned. So I want you to please get a piece of paper and fill in the chart as you follow along in the video. Okay, we're going to take our notes on igneous rocks. So for your notes, let's review. Igneous rocks form by the cooling of magma or lava. The word igneous means fire, so that's one way you can remember igneous rocks form from the cooling of magma or lava related to a volcano. Igneous means fire, kind of like an igniter. If you ignite a fire, you start a fire. Now we are going to make a chart comparing extrusive and intrusive igneous rocks. Remember, these are two types of igneous rocks, extrusive and intrusive, and the difference between them is their environment of formation, or where they form. But because they form in two different places, they have different characteristics and they look quite different. Extrusive igneous rocks form from the cooling of magma. I'm sorry, that's the cooling of lava, right? Because we are on the surface of the earth. The cooling of lava on Earth's surface. And we can remember this by saying the lava exits. It exits the earth, it's on the outside of the earth, and that's where our extrusive igneous rocks form. Because they form from lava that is on the surface of the earth, that lava cools and hardens very quickly. Instead of saying harden here, I'm going to say solidify, because remember, we have our liquid lava turning into a solid rock. Cools and solidifies fast. Rapidly. Rapid means fast. Because these rocks form from very fast or rapid cooling of lava, there is not a lot of time for crystals to form, and so these rocks end up having tiny crystals. We might say tiny or fine crystals. Sometimes they form so fast that they can also have holes in the rock. So let's compare our extrusive igneous rocks with our intrusive igneous rocks. Our intrusive igneous rocks form from the cooling of magma inside of the earth. Or below Earth's surface, intrusive inside. Because this magma is cooling and solidifying very slowly, the magma is cooling inside of the earth, so it can cool very slowly. It takes a very long time for these rocks to form, for the lava, the magma, to form a solid rock. The magma cools and solidifies slowly. And because this is a very slow process, these rocks are able to form very large crystals. So if you look at a rock that is an intrusive igneous rock, you can see with your eye, without using a microscope, the large crystals in the rock. That's all for our discussion of igneous rocks, comparing intrusive and extrusive rocks. I hope you guys have a great day.